Right, hi everyone, welcome back. Hope you can hear me. I'm sorry about the squeakiness in the background. That's the front zip hub. I'll show you that in a minute. But in this video, we're going to look at a little bit of engineering. There's going to be some cutting, some drilling, some 3D design, some CAD, and some carbon fiber molding and demolding. So if you like this kind of thing, don't forget to like and subscribe so it can be shared with anyone else who might find this kind of thing interesting. Anyway, I was contacted a while ago by a guy from Germany. Well, he's actually a Greek guy, I think, but he lives in Germany. And he said, can you help me? I've bought a carbon fiber bike with an integrated seat post. So if you don't know what that is, an integrated seat post is like the one I'm riding. Doesn't have a sliding seat post assembly. And if it's wrong, you either sell it to someone shorter than you or chuck it in landfill. Now, he desperately didn't want to chuck it in landfill because he really likes the bike. I've never seen one of these frames before, I must admit, it's quite old. And he said, can you help me extend the seat post?
Yes, but at what cost?
Well, I said, well, yeah, but if I cost up all this engineering, it's going to cost you quite a lot. But if you don't mind making a video out of it, we'll come to some sort of arrangement, we'll have a bit of fun with it. So we talked about a few methods of, or I proposed a few methods of how to make the seat higher. We looked at extending the kind of saddle clamp. That would have required at least 2 or 3 CNC aluminium parts with some extra hardware as well, some sort of spherical nuts and things like that. And doing those as one-offs would have been quite expensive. So I then proposed just machining an aluminium plug out of 6061, bonding that into the carbon, and he could actually cut that plug down to the height he wants. So he'll make it slightly longer, and he can actually cut it down and make spacers out of the offcuts. I costed that up in CNCing. Now, CNCing isn't very efficient when you're just doing one-offs because it's the machine. It's all about machine time with CNC. That's what you're paying for. It's pretty expensive just to program a machine, just to do a one-off job. If you're making a very thin wall part like this, you might get some errors. You might get some breakages. And then there's the issue of possible galvanic corrosion when we're bonding in the aluminium part to the carbon with no intermediate layer like fiberglass. Possible galvanic corrosion. If he's going to use it on the turbo trainer, it's going to get sweat on it. It's right underneath his bum. Everyone gets a sweaty bum on the turbo. Galvanic corrosion will probably be the biggest thing there. So decided to make it out of carbon fiber. And obviously that sounds seriously complex, but for a one-off it's quite a nice thing to do because there's not much wastage. It's very labor intensive, as you'll see in this video, but in actual fact we made it work quite well. Now, I fixed this bike without seeing it, and it does take the guy down route a level of engineering sympathy or know-how to help me through this process. So I said, well, I need some really, really good dimensions of the inside and the outside of the ISP so I can get the profile right in the CAD. So he went and got a digital caliper, sent me some accurate measurements as possible, and the first thing I actually did was take that shape and some very flat top-down photos. I asked him to take some very flat top-down photos very far away, as zoomed in as possible, to avoid any parallax from the lens, because if you're going to use a wide-angle lens, it's going to distort the image. So a flat photo to get the profile and then some maximum and minimum dimensions would help me recreate the profile in CAD, so I could draw it up in CAD. And then the plan was then to send him basically a trial 3D printed plug to see if I got the shape right. And that was the first thing I did. So I posted him off a trialed 3D printed plug, thanks to UPS, so I could see if I've matched the external shape right and got the internal shape right to allow about 100 microns of bonding gap all the way around. And I mean, I'm not just saying this, but we nailed it first go through a combination of his photos and his dimensions and measurements and my design. We got the profile pretty much bang on. Now at that point I was still looking at making it in aluminium, but as time went on I just couldn't get the machining price down, and I was like, look, do you know what, I'll do it for you in carbon. So then I thought, well, how do I do this in carbon? I've got the final dimensions that I know because I've made the 3D printed part and I've got all the measurements, but if I'm doing this in carbon, you know, the carbon wall thickness is going to come into play, the number of layers are going to affect the outer dimensions. I need to make a plug offset smaller so I know the final dimensions. So I created another 3D printed part this time, but this was going to be basically a mandrel to wrap the carbon around, and I knew the wall thickness of carbon that I wanted to end up with, so I knew how much material to take off for the outer diameter of the plug. The bit of the plug that went into the frame, as long as that's quite a lot smaller, you can fill that gap with epoxy, but we didn't want to put too much epoxy on there. It's about 100 microns or 0.1 millimeters is a good bond gap. So that's what we went with. I made this offset plug, put a 6mm hex up the middle so I could help actually hold it when I'm wrapping it with very wet carbon fibre, because I'm using wet layup for this and then a vacuum bag. So got all the carbon wraps ready, the right amount for the right wall thickness that we needed, got all the epoxy mixed up, and I wrapped it in carbon. Now, why is there this big transition zone between the top part of the plug and the bottom part? Well, that's there so I can wrap the same piece of carbon around the top and bottom at the same time. If I left a very sharp step there, it would have been very hard to use the same ply to wrap around. It would have created a stress concentration. It might have even cut through the ply when I wrapped it tight, and it would have been a very sharp corner to wrap the carbon around. It wouldn't have been possible to do it in the same plies for the top and bottom section. So put that nice transition on there. It'll help ease the stress up and down, and it'll also allow me to wrap the part in one go. So after putting all the plies on, the part was then cured in a vacuum bag. First, I put a peel ply down to give a nicer finish, and a breather layer to make sure that all the vacuum can get to the part. That was then vacuum bagged, cured overnight. Demolded, taken out, cleaned up a little bit, edges were trimmed off and the top and bottoms were trimmed flat. And that exposed then the internal carbon plug. Now, the internal carbon plug is actually the heaviest part of this. I think the whole thing weighs 40 odd grams. And the internal plug, I think it was 23 grams of that. So the carbon is not very heavy at all, but the internal plug, it doesn't really need to come out. It can stay there. It gives it a bit of compressional stiffness, kind of wall stiffness, because the carbon wall is quite thin. So after a tiny bit of sanding and finishing, making sure I got the final dimensions about right, and I'm happy to say, I'm not just saying this came out right first time. This was the first go I had at doing this, and pretty much hit the external dimensions bang on. They were a little bit on the big side, which is fine because it's easier to take material off and add it. But I didn't want to take too much off because I was going to send it to Vasily and then he could fettle it his end to get the perfect fit. So, and I also designed and 3D printed the little cutting guides like I make for the TCR ISP. Printed that for him so he could cut the new plug to the right length and use the offcuts as spacers to fine tune his position after his bike fit. So sent it off, UPS. Did need a little bit of sanding on some high spots to get a nice clearance for the glue, to get a good glue thickness in there. Now Vasily he's got a good mechanical mind, I can tell. Like, he's not rushing things, he's taking measurements, he's measuring thrice, cutting once. Make sure you clean it before you bond it, put everything down, get everything ready, and then clean it again. And just before you bond it, clean it again. You can't clean it enough, so he's cleaned it many times with IPA, isopropyl alcohol. He's bonded it in with an excess of epoxy. The epoxy we sourced from rg.de, which is a very good composite supplier in Germany. It's kind of a general 2-part epoxy, room temperature cure, no problem with that. And he's bonded it in. And as you can see here, supplied me some very nice photos and a little time lapse of him bonding it in. After that, he's had his bike fit and then he's then cut it to the right height and created himself some new spacers with the offcuts. So I'm calling that a massive win. We saved the bike from landfill. He's got the bike he's wanted to ride for a while, and happy days. If you've got a project like this you want looking at, if you're in the UK, I mean, doing it remotely, we did this remotely, I never saw this bike, so I'm pretty happy with that. But doing it remotely was hard. But if you're in the UK, you've got a carbon bike you want repaired or something a little bit custom like this, get in touch with me via the website. I'll put probably a contact form on another page on the website just for carbon repairs, and we'll see what we can do. So don't forget to share that if you found that interesting and enlightening, and see you in the next one.